Alright, so in this video we're going to be going over problem set 8 for Organic Chemistry 2 Fall 2025. So let's get started. There is a lot of nomenclature to be covered in this problem set. So let's get started here. We have this ester, and the key to naming esters is you want to name one side of the oxygen and the other side as its own parent chain. So right here, let's count the number of carbons. We have 1, 2, 3, 4, 5, 6 as the longest parent chain. So we know we have a hexane of some sort. And right here we have 1, 2, so we have an ethane of some sort. So the key to naming these guys is to put this little small bit to the right next to the oxygen first. So this is going to be ethyl with a YL, ethyl. Put a space, and then we're going to name this guy as if it's a normal parent chain. So we have 1, 2, 3, 4, 5, 6. And the two methyl groups are coming off of carbons 2 and 5. So we have ethyl, space 2, 5 dash dimethyl. And like we mentioned, it's a 6 carbon long parent chain, so it's going to be a hexane. But for esters, we're going to name it with an O8 ending. Hexan O8. Alright, that's how you name esters. Let's go ahead and name the second compound here. It's a very similar idea to naming esters. That's how I like to think about it. We're going to name this ion right here and then name the ester as a normal parent chain. Let's go ahead and number this. 1, 2, 3, 4, 5, 6. We have another hexane, and the key to this is just to put the ion name, potassium, space, and then name this guy. So this is going to be 3, 5 dash dimethyl. And same thing applies. It's a hexane, hexan O8 with the O8 ending. Alright, now let's name this third molecule, and this is an amide. Key to identifying amides is a carbonyl group adjacent to an NH group. So in order to name amides, first things first is we want to find the parent chain. So this is the longest continuous chain of carbons, spanning 1, 2, 3, 4, 5, 6 carbons. We have a lot of hexanes today. And because it's an amide, it's going to end in hexanamide. So, you know, that's going to be the ending here. Hexanamide. Not to be confused with hexanamine. You will get points off if you name amine instead of amide with a D. So now let's name this parent chain as normal. We have this two alcohol groups coming off of carbons 4 and 5. So we have 4, 5 dash di, not methyl, oops, hydroxy is the name. And then we're going to put a dash, and we need to account for this methyl as well. That's going to be coming off of the N. So it's going to be named as N-methyl hexanamide. All right, that's how we name those guys. Now let's go ahead and name this. We have another ester, so we're going to name this side first, and then we're going to name this side. So this side we have a single carbon with a chlorine, so this is going to be 1-chloro methyl space. And then we're going to name this side. Find the longest continuous chain of carbons. 1, 2, 3, 4, 5, 6. A lot of hexanes. Another hexane, and we're just going to name it as a normal chain, so it's going to be 4 amino and hexan O8. Hopefully you guys are getting the hang of this now. So now let's name this molecule here. We have another amide. So let's find the longest parent chain here. 1, 2, 3, 4, 5, 6. Man, these are all hexanes. All right, and let's go ahead and name this. So we have how many methyls? We have 1 methyl here, 1 methyl here. So we know we're going to have a dimethyl somewhere. This group here, that's an ethyl. So the ethyl is actually going to take priority. Where's the ethyl coming off of? The N. N-ethyl dash, and then we're going to name the methyls because that comes next. N, 5. Don't forget the dimethyl. There's 2 of them. Easy way to lose points if you're not careful. And then hexanamide. All right. Now let's see this group here. This is not going to be an ester. This is actually going to be the highest priority of a carboxylic acid. So let's find the longest parent chain right here. 1, 2, 3, 4, 5, 6, 7. So we have a heptane of some sort, but we know there is a carboxylic acid, so we know it's a heptanoic acid of some sort. So the functional groups to be careful of here is the chlorine and the double bond spanning carbons 2 and 3. So we want to name that. So let's go ahead. Whenever we have something like this, we need to find out whether it's going to be E or Z designation. And in this case, it's going to be Z. Z for going the same side. That's how I like to remember it. So we have Z, and then we have the chlorine, 3-chloro. And we previously established that it's a heptane of some sort, or heptanoic acid. But the thing to keep in mind here is we want to designate which carbon the double bond spans, and that's always going to be from the lowest carbon. So the double bond spans carbon 2 and 3, so it's going to be hept-2-ene. Don't forget about that right there. And then it's going to end in oic space acid. All right, next group here, we have another hexanoic, or we have another carboxylic acid of some sort, but they're going to be on both sides. So we have a dioic acid. I lied. I was super careless. That is something that you guys should look out for as well. This is not a carboxylic acid. That's an aldehyde. That was super embarrassing. This is going to take priority. So let's find the longest parent chain right here. So 1, 2, 3, 4, 5, 6. 6 carbons long. Don't do what I did. That could have been really bad. 6 carbons long, and we're going to name it accordingly. So it's going to be a hexane of some sort, hexanoic acid of some sort, and everything else can drop down to side chains. So we have 2 ethyls coming off of 3 and 4, so we know we have a diethyl of some sort. I keep saying some sort. So 3, 4 dash diethyl, right? And then we need to account for the aldehyde. And aldehyde, when it's not a parent chain, the side chain name prefix is going to be oxo, which is actually the same as a ketone. So keep that in mind. 6-oxo, and this is 6 carbons long, hexanoic acid. Space acid. Good. Last guy right here, we have another ester. Remember? Whenever we have a carbonyl next to an oxygen, we have an ester. So we're going to name this guy first, and this is going to be the parent chain. So we have this cyclohexane, which is going to turn into cyclohexyl space. It's 1, 2, 3 carbons long, so we have a propanoate. All right, hopefully that all makes sense to you guys. Now let's look at the second page. This is a review of reactions. So we have this benzene here, and we're going to be Friedel-Craftsing this. So we have to remember the different directions that these guys are going to add, and this is going to add in the para direction. This is just something you guys have to know from that $ chart. Very important to memorize the activators and deactivators. All right, so we have this group here. Next, we're going to be treating it with NH2, KOH plus a little bit of heat. What this is going to do is this is going to just reduce this carbonyl group here and kind of just get rid of it. So this is going to turn into a straight carbon chain, right? So now the next step here, we have this H2CrO4 plus heat. This is a very strong oxidizing agent, and it's going to oxidize the side chains, or not side chains, but the groups coming off of the benzene. And the important thing to know here is that it'll oxidize any carbon chain so long as there is a hydrogen on the carbon adjacent sticking out of the benzene. So what I mean is that, for example, this group down here, we have 2 hydrogens coming off here, so an oxidation reaction can occur. But if you guys remember from previous exams, there's no hydrogen coming off here of this tert-butyl. No hydrogen. So this is going to stay put. This is what's going to turn into a carboxylic acid. All right, perfect. And now we have NaOH. And this, as we know, this is a base, this is an acid, and all that's going to do is an acid-base reaction, kind of from Gen Chem, if you guys remember. So that's going to turn this into an ion, and then the sodium is going to float next to it. that's going to be, draw the lone pairs out just for convenience. That's going to be your final answer for this reaction. Thank you so much for watching.